Hi all, I am going to explain in this video how to charge a battery and how to use an emergency light when there is no supply. Let us move into the circuit. So this is the lamp or the light that we are going to illuminate or glow when there is no supply with the help of this battery. Okay. Let us now keenly observe what are the components that we require to design the circuit. We need a single phase AC supply and a step down transformer. Primary will be of 230 volt and secondary will be of 6 volt. Then we need a capacitor, a diode and a resistor, and 3 sets of diodes with 3 resistors. I'll tell you the main purpose of, there are 2 different reasons of connecting this resistor. The first main reason is to increase the current rating. I'll mention the second reason when I explain the circuit. And there is one more resistor connected here. Along with this, we have a 440 ohms resistor also. Then an SCR connected to the lamp, a battery. Okay. We have 3 different cases. Case 1 is when there is a AC supply available. And case 2 when there is no AC supply. And the last case 3 is again when the AC supply is back, when there is an AC supply. Okay. So let us move on to the case 1. Our main objective is to make this lamp to glow when there is no supply. And when there is a supply, we don't want this lamp to glow because there is a supply itself. This is only an emergency light, or the other way of saying, like an inverter used in our homes, we have this lights and fans which turn on when there is no supply. Likewise, this is a lamp or a light that glows when there is no supply. So in case 1, when there is a supply, the lamp should not glow and the battery has to charge. The reason that battery has to charge is this battery will be providing the sufficient amount of potential or the supply to the lamp to glow when there is no supply, AC supply. Okay. So during case 1, when the supply is there, lamp should not glow and the battery should get charged. Let us try to understand how this is obtained. So when the supply is connected to the transformer, it's a step down transformer. So in the across the secondary windings, we'll get the 6 volt AC supply. Now this battery is a DC battery. So we need some sort of rectification job to be done. So we connected these 3 diodes, which actually do the rectification process by which we get the DC supply here. As I said earlier, this resistance is connected for increasing the current rating. The first main reason. I'll tell you the second reason later. Now the voltage 6 volt is available across the capacitor 250 microfarad, which makes it to get charged. So this capacitor is right now getting charged with upper plate positive and lower plate negative. And this diode IN4007 is also forward biased, and the resistor is also having sufficient potential. And right now, through this resistor 5 ohms, after the rectification process, the battery is now getting charged. Okay, one of our objective is attained, that the battery is charged now. Now, next objective during the case 1 is the lamp should not glow. We'll cross verify whether it is not glowing or whether it gets supply to get illuminated or not. The battery is connected to the lamp. It is getting charged. Let us check the other end of the lamp. It is connected to the ACR. Now the ACR cathode is connected to the lower plate of the capacitor, which is already negatively charged. So the anode is also connected to the lamp. So it will get a positive supply. It is forward biased, but the gate terminal of the ACR is also connected to the negative terminal or the lower plate of the capacitor, which is negatively charged, which means gate is not triggered, so SCR is off, which means it is not going to conduct. When the SCR is not conducting, the lamp is not connected, and so the lamp will not glow or the lamp is not illuminated. So both of our objective is satisfied during case 1. So when the supply is there, when the supply is available, the lamp is not glowing as well as our battery is getting charged. And there is a reason of choosing all these parameters. I'll explain why do we have 5 ohms and 10 watts with a simple equation. We have a current limiting resistor 5 ohms 10 watts. The reason behind that is we'll just try to understand how much wattage is available using the Ohm's law. First, we'll try to calculate the current. Since the voltage is 6 and the resistance is 5, by applying the Ohm's law, the current passing through the resistor or flowing through the resistor is 1.2 amps. And the total power or the wattage of the resistor will be 7.2 watts. So in order to have a safe value, we have it as 10 watts. Likewise, the capacitor, as I mentioned earlier, it is getting charged during this case 1. By that instant, we should know how much duration it gets to charge. So it is a 250 microfarad connected with a 22 ohms. And so the RC time constant is 6 milliseconds. The reason for calculating this is the duration should be very small because it has to get quickly charged and it has to retain the charge for a longer duration. The voltage rating of the capacitor should also be noticed that it should not be less than 12 volt, and that is why we would have chosen as 25 volt. Now let us move on to the case 2. See the circuit. As I mentioned earlier, case 2 is there won't be any AC supply and the objective is the lamp should glow and the battery will not be charged right now because there is no supply, so it is not going to get charged. It is only going to discharge and the lamp will be glowing. This is the case 2. Let us now understand how this is happening. Since there is no supply, this capacitor will discharge now and it is going to discharge by this way through the 440 ohms and it is going to get charged by this way in the opposite direction. Right now, the capacitor lower plate becomes positive and the upper plate becomes negative after discharge and getting charged to the battery through this 440 ohms. Now, since the lower plate is positive right now, the gate is getting a positive potential. So the SCR will be on right now because it is triggered. The battery is also connected to the lamp and the SCR is also on, which means the switch is closed. And so the lamp will glow. And one more important point I mentioned before, the reason for connecting this resistance 1 ohm 1 watt is the current should not reverse flow through this way, and for that reason we have connected the diode in the particular direction and with this particular rating. To protect the diode, we connect this resistance. This is the another reason of connecting the resistor. I have explained why do we have this 5 ohms and 10 watts. So the lamp is glowing in case 2. I'll explain. And the case 3 is again if the supply is back, what happens? Now again it is discharged and charged. So it is going by this way, the capacitor. Now during case 3, this capacitor is getting charged like the case 1, which means upper plate positive and lower plate negative. So obviously gate becomes negative. So SCR is off and the lamp is not connected. Hence the lamp will not glow, whereas the battery is connected and so the battery gets charged. So case 1 and case 3 is almost same. And case 2 is where we make the lamp to glow by using this battery. So this is how we try to glow or illuminate this lamp using an SCR. You can check the case 2 also. See here, the charging time during the case 2 of the capacitor should be 20 times lower than that of the case 1 or nothing but the previous charging time. And for that reason, we have connected a resistance of 440 ohms, half watts. And also to make the SCR in a safe operating range, we have this calculation. You can check it. And now the SCR gets a positive polarity and so SCR is conducting the case 2. This is the reason of selecting the SCR with this particular current and voltage range and as well as also this resistance connected 440 ohms half watt connected in the circuit. Hope you understood the explanation. If you have any queries, you can put it in the comment section. Thank you.